I'm Susan Strome. I'm in the Department of Molecular, Cell, and Developmental Biology. I teach genetics, Biology 105, which is taken mainly by juniors, with some sophomores and some seniors. I have been at UCSC for almost 8 years, and before that I was at Indiana University for 23 years. We are trying to define how certain cells in the early embryo know to be germ cells and to give rise to eggs and sperm. Everything I do in research affects what I teach. And I think it's important for the students to see the applicability, the application of what we're teaching in genetics, and not just think that it's vague concepts that we teach them to torture them. My philosophy is not to overwhelm the students with lots and lots of superficial teaching of many things, but to identify the key concepts that I want them to leave the course understanding deeply, and then to teach those from multiple angles. Maybe my style is goofy. Sometimes I do sort of zany things that really make them laugh, and I make them stand up on stage with me and do skits. I try to convey that I enjoy teaching a lot. I enjoy the material and hope that they'll adopt some of that enjoyment. I'd say for me, the real transformation in teaching came from participating in a workshop at Indiana University that was, it involved veteran teachers that were good teachers, but were interested in being better teachers. And we all worked together for 2 weeks. And these were teachers from biology. I had a friend also from biology, poetry, criminal justice, history. So many different disciplines. When we went into the workshop, we all were supposed to identify a bottleneck in the course we teach, something that the students really struggle with, and then figure out a way to teach it. So we did a lot of exercises through the 2 weeks of the workshop, and we met together probably 5 hours each day. We talked a lot, we worked with each other, and we all had to come up with a sample lesson to teach our bottleneck concept to each other. That was the most nervous I've ever been giving any lecture, talking to my peers who were really good about something that I desperately wanted to teach better and they knew nothing about. But that was the beginning for me of sort of a journey of trying to figure out ways to better teach each of the critical concepts in genetics. For me, the bottleneck was chromosomes, because the behavior of chromosomes underlies much of what we teach in genetics. But I was really disappointed to learn over the years that even students graduating from my class really didn't understand chromosomes well. So I hold chromosome workshops, and the students cluster around tables with pipe cleaners and beads to represent different chromosomes. The pipe cleaners are chromosomes and beads to represent genes. And just the act of saying, set up a 2n = 6 cell, is when they say, what am I supposed to do? What am I supposed to grab? How many chromosome pipe cleaners? What colors? How do I load them with beads to represent the 2 homologs? So we do that kind of exercise. That approach doesn't speak to everyone, but for some people it's the light going off. They say, oh. I should say too that I do a pre-quiz on chromosomes before we start talking about them in class. So students have heard about chromosomes and mitosis and meiosis maybe since middle school, certainly since high school. So I do a pre-quiz where I'm asking them which of these cells accurately represents mitosis, meiosis 1, meiosis 2, or none of those. And I collect those from 300 students. And they're shocked when I show the results in the next class period. And the number of students who nailed each component was 7 to 10%. In other words, they've heard the terms, they think they've learned it, but they don't know it. And then they're more receptive to my saying, let's start at the beginning. Let's really establish the basics. I'm organized, and so I've organized my thinking into outlines that the students can pre-download and then fill in as we march through the class. But it's not pure lecture and outline filling in. There are some PowerPoint slides, we have skits, we have occasional videos, a lot of problem solving in the class where we break we take a break from discussing what we're discussing, and I have them solve problems. And I use clickers in class and break up the class session, which is an hour and 45 minutes, at 8 in the morning, Tuesday and Thursday. That class needs to be broken up. And so we do clicker questions every maybe 15 minutes. One of the aspects of teaching genetics for so many years is I know what confuses the students. I can tell them in advance what will confuse them. They don't always listen, but I know what will confuse them, and I pay a lot of attention to trying to teach those concepts better. You know, trying to come up with innovative ways to teach those concepts where we write it out on an outline, we show PowerPoint slides, we do skits, we solve problems in class. It's just trying to tackle these important concepts from multiple angles so they get it, instead of whizzing by concepts where they hear many of them but don't get many of them at a deep level. So the extra credit question comes on. I tell them to talk to their neighbors and click in, and the place just goes abuzz, you know, and they're clicking in, and I can watch the answers. And I can see, sometimes what I can see that's really interesting is the answers are spread over 1 right and 4 wrong, because it's all multiple choice on clickers. And I can see as they talk that they consolidate onto the right answer. And that's great when the students are helping teach each other and they're getting to the correct answer based on their discussions and realizing their previous answer might have been wrong, and so they can change it until I call time. And then I highlight the answer that's correct and they, yay! It's really neat just seeing them get all excited about tackling a problem and getting it. Those are the moments I really like, is when the students are yammering away, talking to each other, trying to solve a problem. I had a group from Wisconsin come in and evaluate one of my classes. It's just a teaching study, and they asked if they could visit my class and do a survey. I said, sure. So Matt Hora was my contact, and he sent me the outcome of that study. And so he surveyed the students after the class. And one of the questions was, do you feel comfortable asking a question in the class? Well, I know lots of students ask questions, but many of the students surveyed said, no, they're not comfortable. That's intimidating to them. So the University of Wisconsin contact said, you might invite students to ask questions, you know, be overt about it. So the next class session, I said, be sure if you don't understand something to ask me. If you don't understand it, there's a good chance someone else doesn't understand it. And that session, all of a sudden, many more questions from students I had never heard from. And I like going off on tangents because it makes the students feel empowered to drive the course a little bit by their interest. And sometimes students send me interesting articles they've read or questions they have, and then I try to highlight those in the next class session. I feel like having the students sit in a theater actually impedes doing what I would really like to do, which is to have them turn and look at each other, be in a little circle of people, and be working together this way instead of maybe talking sideways but aimed up at me. And certainly when we try to do chromosomes, I used to do chromosomes, I gave everybody a set of chromosomes back at IU when my classes were smaller. And even though they had desks, we weren't at tables, they could all work with them. And now I feel like we can't do that in this big class. I would really like to have a setup where the students are sitting around tables and where they're connecting to each other. It is so fun to see the students enjoy the material and get it. It's the get it, the aha, that to me is the most satisfying. Sometimes in the evaluations there will be comments that just thrill me, like I've heard mitosis and meiosis for years and I never understand it and I finally get it. I'm thinking, yes. So that's, I guess, what I find really exciting.